Hey, I can't believe IP figured out the problem, the solution, the cause to this problem that was every once in a while, uh, our master pipeline would break and stay broken in weird ways when it was trying to compile the front end assets. Uh, so yeah, what was going on, IP?
Yeah, let me share my screen. Firefox dev. So we had a few broken master pipelines, and the first thing, if you deal with a broken master and compile production assets, the output from Webpack is so large that we shove it into a file, so you won't see the failure directly in the output, and you basically need to go into a file to find what happened. And even then, in that file, the output, the error might not be the last thing you need, so you need to search for it. Um, that being said, like yesterday we had a funny failure, and people started digging into it. And in one of the logs, you could see, hey, in this file, work items, components, work item state batch, it wasn't able to load a query, which is very curious because this file doesn't even load the GraphQL query at all, right? What's more curious is that this error happened at some times and it didn't happen in others. And we also have some heavy caching. So in case our source files didn't change, we might download the assets from elsewhere. So pipelines might be passing in case one of if another compiled production assets job passed in some completely other unrelated pipeline. So Webpack might not even be executed, right? Um, in order to try tracking things down, one little trick that was employed was I just went in and parallelized the compile assets job so that each pipeline would trigger 10 of them rather than just one, because it's easier to trigger like 3 pipelines than 30. And without further ado, we had quick success and had saw that suddenly, like here, 2 out of 20 jobs were failing. In this one was failing, and in this one, 5. So we had like out of 60 build jobs, 7 or 8 were failing. And then I basically reverted a change that happened before. Like this is one of the files that is mentioned in the stack traces, and it was changed one commit before we saw the flakiness. So reverted that change, and boom, the flakiness was gone. What was also interesting is I mentioned we have this work item state batch view, but it actually shows the contents of what's the name of the other file, of the user achievements one. But looking into those 8 failing jobs, we actually see that the thing between the two is flipped. So it seems like sometimes the user achievements view one is having the content um, of the state badge one, or vice versa. And so this was tricky. But basically also because we confirmed in this MR that reverting the change fixed it, we just reverted the change as the first thing. Today, the exploration continued. And I mean, it's super curious that, you load one file and you get the contents of another. So actually in this MR already, we added just some echoes and cats, just some cats of the contents, and the contents on disk were definitely correct. And I mean, like 90% of the time, the thing was passing as well. So then I created a branch where I reintroduced the changes, and then bit by bit added like some more logging to it. So show latest version. Let us go to the versions. That will probably help. Master to version 1. So this is very similar to the other MR that we've shown. Like after the remote is merged, we are adding the changes again. And we're adding the parallelization to get more output. And then we basically add some logging. And because getting the wrong file hints at that maybe some caching is going wrong because the contents are correct at disk, you really don't hope that the file system is broken.
Yeah.
Added some logging to Babel because every view file gets transpiled or gets parsed and compiled by the view compiler and then by Babel. So added some logging to Babel, and the outputs of those didn't really change anything, show anything. In the next version, version 1 to version 2. Yeah, then we just forced that everything is compiled. This was like that thing that I mentioned before, that sometimes stuff doesn't get compiled. And then just adding way more logging, right? Because we knew that these two files are affected, I always added like a statement, in order not to log too much. I added a statement, hey, if one of these files is currently being looked at, then log something.
I want to say that um, this is such a good debugging tool of being able to patch dependencies for logging.
Yeah.
Um, maybe afterwards for those that are watching that aren't familiar how to do this, it'd be helpful to show how to uh
How to do it. Yeah, let's do it after this. Let me just also prepare my screen a little bit for this. So yeah, you can see the thing that I also employed is like simple console warns, and then also depending, I use just what for Babel, what cache for Babel cache loader, and for the view loader, because those are the three loaders that are employed. I used what view, maybe added like a little bit more context so that I know if I have the log, what happened. And then if you actually look at the pipelines of this, let me see where stuff broken. Like here we have actually a pretty good failure. 500 assets, I assume. So let's scroll all the way down. And so let's see. Yeah, here you can already see it. Here we have the file, what item stage badge, and you can see get user achievement. So this is definitely the wrong content for this file, right? And if we go up, we can see that, hey, like one of the first things we load is like this source file is already the wrong one, right? And so you go up and up and up and see that this is the wrong one. So our logging actually hinted at, hey, even before the view loader did its thing, so just loading, like already in the view loader, we already had the wrong source code, right?
Yeah.
I then quickly, let me just go from 3 to 4. What do we have here? Yes. Looking further, before the file even hits the view loader, it is parsed by view single file compiler. And so then it was really easy, and I just did that locally. I employed the same logic we had before, where I was like, hey, if it's one of those files, please log me the cache key, and it immediately showed that the hashSum that was calculated here was the same for the two files. We did some calculations, math, that we had a probability with about 3,400 view files of 1.3 in 1,000 that there was a hash collision here, because the latter part is static, so it's the same for all, and these two are
And
and
it's
it's just sorry.
Oh, I was saying it's interesting note too, like the damage once there is a collision, it's there, like it's stuck. Like
Yes.
it's not like on every run we have this chance of a collision. It's based on our based on the contents of our Git repo. And once there's this collision between two files at all, like all
Yeah.
pipes broken until those files change.
Yeah, exactly. And the thing is, why did we just see it a few times? Because the parser in Vue just keeps the cache of the last 100 files it touches or parsed. I assume it's just in order not to blow out of memory. And just imagine you have like one file that's used very often. So I assume like because this is a cache that I don't know exactly. I assume it's a cache that's smart, maybe it keeps the things longer in the cache if they are retrieved more often. You see cache get here, right? Or maybe it, I don't know, right? But so this is the reason why we sometimes hit it, because I assume the order in which Webpack compiles things might not be deterministic. So sometimes within the cache of the 100, both files would be in there or would be requested while the other one was still cached, and leading to this problem. We're still debating how to fix it. Interestingly, in Vue 3, they don't cache it at all. And they also have a larger cache of 500 files. I mean, I don't know how large the average Vue file is, but you can do the simple calculation of, hey, if you have the source code, I don't know, uh, of 500 files or 100 files, and it's 20 kilobytes times 100, it means 2 megabytes are used for the cache key. So I assume that at the time, this was the motivation between hashing the source and the file name, just because it's way smaller. Yeah.
Yeah.
And by splitting the hashing into 3, you increase it's much more unlikely that you have a collision on file name and source at the same time. Yeah. So this is like what led to the debugging. Also triggered 3 pipelines again with 20 jobs each and saw that all of them pass. And then I basically cleaned up all the commits, like all the stuff that we had for the debugging, right? Yeah, so, removed all the debugging that we had for the, this is funny syntax editing. But yeah, removed all the things that we added, to these other loaders. And so we are left with what happened in the compiler.
Yeah.
Um,
That's wild.
what What's really dangerous and interesting, though, is that we only hit, like, it's a very minuscule chance, like 1.3 out of 1,000 that this happens. Then they also needed to be in the cache at the same time. And now comes the gimmick. Either of those, like one of those, needed to have a relative import, because the actual failure in Webpack was that a relative file could not be loaded, right?
So get this.
So
That's actually the worst case is, well, actually, if the pipeline didn't fail, because we could
yes,
actually have successfully built and deployed a GitLab where two Vue files were flipped.
exactly. And then you might have a runtime error, right? Like, because you
Yeah.
want to show the workstate badge, but it actually loads the get user file component. So like this is a really, really big issue, right?
Yeah.
Uh,
Yeah.
I,
It
I,
is.
I, 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 Unfortunately, Vue 2.7, which we're on, is in maintenance mode, and so I don't think they will accept the patch, but it probably makes sense to raise an issue.
Yeah.
For ourselves, we probably should debate whether we want to do the hashing at all. Given that we are a larger Vue project, we should actually maybe calculate
Right.
how often we hit the cache, just in order to see, because if we just have a cache hit rate of 1% here, or like even less, you probably can forego the cache altogether, right? And just be like, hey, boop.
Yeah.
Um, yeah. So I don't know. But this is just interesting. I think the most interesting piece for people who debug stuff is to know how to patch a package, potentially. and it's super simple. And the other thing is how to that if something fails in CI, and especially if it's not reproducible, the parallel key is your friend, because you can just, multiply how often that job is run
Yeah.
really easily with one line change.
Do you have that? Do you have that MR open?
Yes, I have this MR open, yeah.
This is the one that we yeah where
Yeah,
yeah and those and in hindsight it's like in hindsight me accusing I think the file system's broken is like so naive. Of
yeah,
course it's JavaScript.
exactly.
But yeah, using parallel 10 is a great takeaway. Yeah, if you could show how to patch
Let
and
me
that'd be cool.
Yeah, let me reshare my screen. So yeah. So I'm going to pick a random package. Let's use some random dependency. What I also learned to this process, it works with nested dependency. So maybe let's do that.
And
Um,
that's the other really wild thing I just noticed too, because we have the Vue compiler SFC as a top level node modules dependency, but that's not the one Vue uses.
yeah,
And that one doesn't have I couldn't find the same hashSum stuff. Uh
yeah. So if you are like let's imagine this one, BNJS. I don't even know what it does, right? I'm adding like inherits here, console log, hey YouTube. I don't know. um, so the thing that you just do is, let me increase the font size, is you copy the path right where this is. And you do yarn run patch package, and you paste this,
mhm,
and you remove the file path because that doesn't matter.
mhm.
You remove all the node modules you have in here.
Oh, really? Okay.
And that's it.
Okay.
And what it does, it creates like a temporary install. It creates a patch. And so if we are looking at the patch, this is the patch. Hey, this is
Or-
a node modules browser refi app and s. Hey, you want to add the console log.
Cool.
And so if we now RMF node modules, this is probably going to take a while because it's a big folder. Should have maybe done
Should
it
just
before.
renamed it.
Yeah, that's cool. Um, and if we install things again, um, beep, 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 beep.
But while it's doing that, so it sounds like this isn't baked into Yarn. This is like a dev dependency that handles this patching.
Yes, it is. I think newer versions of Yarn might be able to do it natively, and I know that PNPM definitely does it natively. The
Mm,
good thing about the PNPM, I know it's compatible with this package. You can see now that it's patched here. It's compatible with the patches here.
mm.
So it would just, if we move to PNPM, it would just work out of the box.
Yeah.
Um, but if we go back to BNJS, we see, hey, this is patched. And we actually use this a little bit to help with our Vue 3 migration. And we also use it on Rail on another package to remove some functionality, right? That otherwise is not being able to be removed during runtime code. We just remove it here.
Yeah.
Um,
It's definitely sounds like something that, try as hard as possible not to do unless you absolutely have to do it. And in this case, I think we'll have to fix this bug.
yeah. On
Yeah.
the other hand, it's like if it's like something like this, like a one-line thing to change that hash function or something, where you also expect that no new version of an old package will be published, it's a way quicker way to get the dependency fixed compared to
Yeah.
forking the dependency, publishing it yourself to npm, and these kind of things.
Yeah.
Like,
Can yeah, totally. Can we I know I know this is getting a little longer than we thought, but oh, there's also time. Um yeah, I wanna have you dove into that hash sum function? Have you dived into it and like why it could be causing collisions? Because I was thinking, well, when you first told me
oh, it's pretty simple. Pretty simple. So basically, that hash sum function has is it entropy? So it has the 2 to the square of 32 possibilities, right?
Hmm.
And from there, it's just math. It's just math. So like you have 32 bits of randomness, and so if you have an equal distribution,
Oh,
you
is
would
it
end
are they
up.
making sure that the hash is only like a certain size too? They're not like
Yeah, exactly, right? Like,
uh,
let me
oh
let me.
no. Okay. But then I see what you're saying. I wasn't sure if it was like, actually gonna have, deal with
So
like
it's just this example that's like counterintuitive, right? Like, so for example, you see here, um, this is actually for like this example, like this hashing function, and assume it's perfectly equally distributed.
mhm.
Might not even be the case, but if it is, it just shows that there's a 50% of collision if you have 77,000 elements, right? And this is a little bit ridiculous because if you look at it, um,
I go to Wolfram.
Wolfram Alpha, yeah. I mean, 2 to the power of 32 is like
It's
4
like,
million
yeah,
something.
yeah.
No, it's 4 billion, right? Like you only need 77,000 elements in order to get like a collision within a realm of 4 billion at a 50% chance.
Yeah. And ours
And
have you were saying ours is still just a fraction of a percentage.
yeah, and but it also like the odds, like it's a little counterintuitive, right? Like you can see hash values. We are somewhere between 3,000 and 9,000, and so the odds are something between 1 in 100, like 1%, and 1 in 1,000. And I mean, hitting a 1% chance just with the number of iterations that we do on view files is not that unlikely, right?
Yeah. That's
I
wild.
mean, you need to think of all the permutations that we have in view files. And you also can see like how counterintuitive is if it were like using a
Yeah.
64-bit number, the chance would be like, I don't know, right? To have the same chance, we would need 192 million view files. And to be
Uh,
honest, I hope I don't work here anymore if we have 192 million view files, right?
I think
Um,
yeah, we yeah, someone introduced a view file generator at some point, and then it just, this game.
Yeah,
Uh,
or to put it differently, like the chance actually is 1 in a trillion, right? Like if we, and
I
what's
think a point.
so maddening for me about it a little bit is that if you look, I mean, now I have my code editor open, we can find it, right? Where is it? So hash. So this is the original one, right? So, and here we see that the cache has a size of 100. So what does it mean? It means like in our case, I wonder what the hit rate of the cache is. And I also wonder, um, I mean, how much work are we really preventing here, right? And what is the difference of this hash sum over, for example, using
Yeah,
SHA-256?
yeah.
I mean, SHA-256 is actually at the realm of, it's even 4 times larger than this. So you know, it's almost impossible to hit a collision. If we were to hit a collision with our view files, we would be able to write a paper about it because, as far as I know, there are
Exactly. I
no.
know, right? That's what I was like. I was like, did we do it? Did we find it?
Yeah. And
That's funny.
so, and
Yeah.
so, like, the question is, like, for example, I mean, this is interesting. Like, how many calculation can this do over SHA-256, which might even be hardware implemented
Yeah.
in some CPUs? And how much time are you saving? Is it really worth it to hash it?
Right.
I mean, the hashing kind of makes sense if you are memory constrained, and maybe this is because this is like 4 or 5 years old. This was like where it made a bigger difference, maybe that, whether a cache takes like 10 megabytes or 2, right? But yeah.
Yeah, that's really interesting. Yeah, no, thanks for diving into it. Yeah, no, and thanks for letting us record it. I think it'll be really helpful for I'm gonna share on the channel and across our team because I think the debugging technique is really interesting. This problem is really interesting. It's just a good thing to meditate on. Like you got to think about how often a thing runs, collisions of, how many times do we assume, oh, this isn't going to run that much, and we can cut corners, but sometimes the effects are big.
Yeah,
Yeah, I think this is a really great case example. And thanks for finding the fix. I'm so wow. That was really great.
cool.
All right.
Thank you.
I've got to hop off in another meeting. I'll catch you later, IP.
Bye bye.
See you.